Hi, hello. I'm Kiran Kumar from Nature of Physics. Today topic is pure capacitive circuit. First one resistive circuit, second one inductive circuit, now capacitive circuit, third video student. Please do like and subscribe my channel Nature of Physics student. Now here AC supply is connecting to the capacitor of capacitance C. AC voltage V is equal V naught sin omega t is taken as 1 student. Okay, so that the capacitance across the capacitor C is equal Q divided by V student, basic formula. From this, potential V is equal Q divided by C. So the potential difference across the capacitor due to the applied voltage student. Now I can write there Q divided by C, which is equal to V naught sin omega t student. And continuation, next step is Q, which is equal to V naught C into sin omega t. And next step, differentiation on both sides student, dq by dt, which is equal to V naught C common d by dt of sin omega t student. And continuation, here dq by dt give the current I student, rate of flow of charge is called current. And continuation, V naught C, differentiation of sin omega t is cos omega t, and omega is common student, okay, in the numerator. So I can write there I is equal to V naught divided by 1 by C omega into cos omega t student, and I, which is equal to V naught divided by XC cos omega t student. XC is the capacitive reactance students. And continuation, I, which is equal to I naught cos omega t written. This is written as equation number 2 students. In this equation where I naught is equal to V naught divided by XC, this is, I can write equation number 3 student. So clearly we can write this is the maximum current, this is the maximum voltage. Maximum current is equal to maximum voltage divided by XC. XC is the capacitive reactance. Okay student. And continuation, next we can write here I, which is equal to I naught cos omega t, we can write as sin omega t plus pi by 2 student. This is, I can write as equation number 4. So from equation number 1 and 4, one thing we can clearly notice that student, current leads the applied voltage by pi by 2 or 90 degrees from equation 1 and from equation 4. Okay, and I is equal to I naught cos omega t. See here sin omega t for the applied voltage for current is I naught cos omega t for current student. So that from this equation also we can understand here phase difference is pi by 2, that is current lead student, because of plus pi by 2 we are getting in the derivation. Okay, and continuation, next step here I got XC student. XC is the capacitive reactance, that is 1 divided by C omega student. Okay, and continuation here XC, which is equal 1 divided by C, omega value is 2 pi f. F is the frequency, and there is a graph student, XC and omega and f student. From this equation, XC is inversely proportional to the omega student. Okay, and also XC is inversely proportional to the 1 by f student. From this equation we can write XC is inversely proportional to the f student. So that here we will get between the graph XC and omega or frequency hyperbola we will get student. And next one is, that is XC is inversely proportional to C student. See there, from this relation I wrote XC inversely proportional to C. The graph also clearly given XC versus C student. So here also we are getting XC is inversely proportional to C. So inversely proportionality is there, that's why we will get hyperbola, student. And next one we will discuss about the I naught, student. I naught is equal to, we got V naught divided by XC, that is equal to I naught is equal to V naught divided by 1 by C omega, student. Okay, so I naught which is equal to, that is V naught C omega. So like this we can write about this equation of XC relation, student, and maximum current equations also, student. And there is a phase diagram, we have to discuss about the phase diagram. In the phase diagram, this is the current is taken I, that is taken as IRMS current, student, and this is taken as voltage across the capacitor. Both have the phase difference, pi is equal 90 degrees, student. Current leads the applied voltage, that's why here this is the graph represent the applied voltage, student, and this is the graph represent the current, student. Current is leads the applied voltage. Okay, and this diagram is wave diagram and this diagram is phase diagram. And continuation, next we will discuss about the power, student. So for this power, so that instantaneous power first considering, student, instantaneous power. Okay, so for instantaneous power, P instant which is equal to Vi, student, and P instant which is equal to V value which is equal to V naught sine omega t, and I value from equation 2 writing I naught cos omega t, student. So P instant which is equal to V naught I naught divided by 2 sine omega t cos omega t, student. Here 2 multiplied and divided, so that P instant I can write like this: V naught by root 2, I naught by root 2, and sine 2 omega t, student, that is 2 sine omega t and cos omega t, student. Now I can write this is the power equation, equation number 5, student. Okay, after P instant we will discuss about the average power, student, so that I can write here P average. Okay, so AVG average power heading, so that average power equation P average which is equal to, we have to write the equation, basic equation for the average power, P average which is equal to integral 0 to t P instant into dt whole divided by integral 0 to t dt, student. This is the equation for average power. And continuation, P average which is equal to 0 to t, P instant value replacing there, V naught by root 2, I naught by root 2 sine 2 omega t, student, whole into dt whole divided by integral dt is t 0 to t, student. And P average, next step I can write V naught by root 2, I naught by root 2 integral 0 to t sine 2 omega t into dt whole divided by t, student. So here upper limit minus lower limit replace, otherwise one more step we can write t minus 0, upper limit minus lower limit, and this value should be 0, student. Integral sine 2 omega t value should be 0. So finally I am getting 0 into anything 0. So P average which is equal to 0. Now I can write this is equation number 7, student. Here one more step I wanted to write for this average power, student, sorry, instantaneous power, P instantaneous which is equal to VRMS IRMS into sine 2 omega t, student. This is I can write as equation number 6. So V naught by root 2 is VRMS, I naught by root 2 is IRMS. This is clear information about the pure capacitive circuit, student. Here also power curve taken, student. Okay, so power on the y-axis taken and the x-axis is time taken, student. This is clear information about the pure capacitive circuit. Okay, thank you, student.